Hostile worlds, bad systems, cosmic mistakes, ordinary people caught in forces too large to fight. These aren't stories about heroes, they're stories about endurance and what breaks when technology outpaces wisdom. Strap in, check your air. This is Vicious Planets. Vicious Planets, Season 0, Episode 9. The Land Grant Terraformers.
AKA, clones got too expensive, so they threw rednecks at the problem, Part 2. Yeehaw! Sorry.
By Morgan Olson. A public access transmission from the outer limits of administrative sanity. Recorded testimony, terraforming contractor Darnell Okafor. Filed with the Interstellar Agricultural Oversight Board, transcript corrected for transmission static. Witness requested that his middle name not appear in the final record. Request denied. I don't tell this story much, not because it reflects badly on anybody, well, not on anybody I like, but because the telling of it tends to make people uncomfortable in ways that are hard to predict. Orbital folks get quiet, academic folks get defensive, corporate folks start looking at their watches. The ones who find it funniest are always farmers. Make of that what you will. The transfer station. Waypoint Bravo-7 is not a place anyone goes on purpose. It sits at the edge of the transit corridor between the inner colony systems and the outer agricultural zones, which is a polite way of saying it sits exactly far enough from everything interesting that nobody with options chooses to stop there. The food is adequate. The berthing is adequate. The common areas are aggressively beige in the way that suggests someone once made a deliberate decision about the color and has been regretting it ever since. We were there for 4 days, waiting on a cargo transfer that kept getting delayed for reasons that were never fully explained and that I stopped asking about after the second day. There were 11 of us at that point. Jed Barnes, who most people have heard of by now if they've followed what happened on Big Blue Miner. Paz, Dr. Maricela Vasquez, who had flown in from a research posting on one of the outer ag moons and arrived with a duffel bag and 3 boxes of soil sample equipment and an expression that suggested she had opinions about the flight catering. Heike Brandt, who had brought her own coffee from Earth in a vacuum-sealed container the size of a small dog and shared it with nobody, which the rest of us respected even if we didn't enjoy it. And 7 others whose names I'll leave out of this because they have families and careers and didn't sign up to be part of a story that gets told at dinner tables. And me, Darnell Okafor, Livestock Systems, Nebraska Sandhills by way of a doctorate from Iowa State that I mention here only because it becomes relevant later. We ate together in the common area because there wasn't anywhere else to eat and because 11 people waiting on a delayed cargo transfer in an aggressively beige waypoint station develop a certain solidarity whether they plan to or not. That's where we were when Dr. Alistair Fenn found us. Dr. Fenn. I want to be careful here because I don't think Alistair Fenn was a bad man. I've thought about this a lot over the years, and I keep coming back to the same conclusion. He was a man who had been correct about things for long enough that he'd stopped checking. That happens. It happens to good scientists. It happens to careful people. The world rewards confidence and punishes uncertainty, often enough that after a while, you stop being uncertain even when you should be. Fenn was Orbital Academy, Ganymede Institute, which at the time was considered the premier institution for applied atmospheric soil science in the settled systems. He had a publication record that was genuinely impressive if you were reading the abstracts and not the methodology sections. He had the kind of bearing that comes from being the smartest person in most rooms, not arrogant exactly, but settled, certain. The look of a man who has already done the calculation and is now waiting for everyone else to catch up. He introduced himself to the group and explained that he had been assigned as the project's senior ecological consultant and that he wanted to take some time before we reached the target world to brief the team on the soil science fundamentals they'd need to understand for the mission. He had a presentation prepared. Jed looked at me across the table. I looked at my food. We let Fenn talk. The briefing. He started with nitrogen fixation. This is a foundational concept in soil ecology, the process by which certain bacteria convert atmospheric nitrogen into forms that plants can actually use. Without it, most terrestrial agriculture collapses. It is genuinely one of the more important biological processes on any planet that wants to grow things. Fenn explained it clearly and correctly. He explained it the way you explain something to people who have never encountered it before. Paz had published her first paper on nitrogen fixation dynamics in low-water perennial systems at the age of 26. It had been cited 412 times at last count. She ate her dinner without expression and did not interrupt. Fenn moved on to microbial soil inoculation, the process of introducing specific bacterial cultures to new soil environments to kickstart biological activity. He cited a paper. The paper was by someone named R. Okafor. I am R. Okafor. The R stands for Roosevelt, which is also in the record, despite my feelings about it. I did not say anything. I had 2 bread rolls left, and I was rationing them. Fenn moved on to root system architecture and its role in atmospheric soil preparation. Specifically, the way deep-rooting plants can access mineral moisture unavailable to shallower systems and gradually build the conditions for broader ecosystem development. He described a mechanism that Heike had spent 11 years studying. He got the mechanism mostly right and the timescale significantly wrong. Heike put down her fork. The first correction. The lateral spread timeline you're describing, Heike said in the particular tone she uses when she is being patient, assumes a temperate moisture gradient. On the target world, the gradient will be primarily thermal. The timeline is off by a factor of about 3. Fenn looked at her. This was the look. I'd seen it before on other people in other rooms. The slight recalibration happening behind the eyes. The reassessment of who is speaking and from what authority, and whether the correction requires engagement or can be redirected. The models I'm working from account for environmental variation, Fenn said. Which models? The Brandt-Schiller atmospheric root propagation studies, the 2187 series. Heike picked up her fork again. I'm Brandt, she said. She ate a piece of potato. The 2187 series, she continued, was preliminary work. The correction factor for thermal gradients is in the 2189 follow-up. You want a factor of 3 on the timeline. I can send you the paper if you don't have it. Fenn wrote something down. The table was quiet in the way that tables get quiet when something has happened that everyone has noticed and nobody is going to acknowledge directly. Jed refilled his water glass. I finished one of my bread rolls. Fenn continued the briefing. The manifest. He moved on to atmospheric soil preparation, specifically the use of engineered microbial systems to introduce biological activity to worlds with minimal existing ecosystems. This was technically his area of primary expertise. His publication record here was legitimate. His methodology was sound in the controlled conditions it had been developed for. It was also, we already understood, going to be inadequate for what waited for us on Big Blue Minor. The native mite systems there required a different approach entirely, one that worked with the existing biology rather than attempting to replace it. We'd been discussing this among ourselves for weeks. We had the outlines of a plan. Fenn was describing a plan that would, in our assessment, cause serious damage to a fragile native ecosystem that had been waiting a very long time for the right kind of help. But we hadn't said any of this yet. We were eating dinner. Fenn finished the microbial section and moved to logistics. He explained that for the mission manifest, he would need everyone's legal names and institutional affiliations for the project record. Corporate protocol. Standard procedure. Nobody argued with it. He started at the far end of the table and worked his way around. The first 3 names were people Fenn didn't recognize. He wrote them down without reaction. Then he got to Paz. Dr. Marisela Vázquez Reyes, she said. Universidad Autónoma de Nuevo León, Agricultural Ecology, currently affiliated with the Outer Ag Moon Research Consortium. Fenn's pen slowed slightly. Vázquez Reyes was a name in the literature. Not a famous name, not yet, but a name attached to 2 papers on mycorrhizal networks that had been generating quiet attention in the right circles for about 3 years. He wrote it down and moved on. Heike gave her name and institution. Fen wrote it down with the careful neutrality of a man who has just realized he cited someone's preliminary work to their face and is hoping nobody brings it up again. Then he got to me. Darnell Okafor, I said. Iowa State. Livestock Systems and Applied Soil Microbiology. The pen stopped. He looked at me for a moment. The R. Okafor, he said. Not quite a question. The paper you cited earlier, I said. Yes. He wrote my name down. Then he got to Jed. Jed gave his name and institution and waited. Fen wrote it down and looked at it. Then he looked up. Barnes, he said. K-State Soil Microbiology. That's right. You wrote the Barnes Protocols. The Barnes Protocols are a set of field procedures for rapid microbial ecosystem assessment in low organic environments. They are used on approximately 60% of active terraforming projects in the settled systems. They had been cited in Fen's presentation twice without attribution, which Jed had noticed and I had noticed, and which neither of us had mentioned. I did, Jed said. Fen put his pen down. He looked around the table. He was doing the arithmetic, Heike Brandt of the Brandt-Schiller studies, Vasquez Reyes of the mycorrhizal network papers, which he'd read and filed away as promising early career work from someone he expected to become significant in about 10 years. R. Okafor of the nitrogen fixation study he'd cited 40 minutes ago to the man himself. Barnes of the Barnes Protocols. 11 people eating dinner in a beige Waypoint station. Combined publication record that I later calculated out of mild curiosity at somewhere north of 3,000 citations across 40 years of field research. None of it from orbital academies, all of it from places with cows. The decision. To his credit, Fen did not immediately become defensive. He sat with it for a moment, drank some water, looked at his notes. I watched him working through something. The recalculation maybe of what this project actually was and who these people actually were, and what that meant for the approach he'd been planning. I thought, briefly, that it might go well. Then he straightened up. I appreciate the depth of experience at this table, he said, in the tone of a man who is about to not appreciate it. I want to be clear that the ecological methodology for this project has been approved at the institutional level, and I'll be proceeding with the planned microbial deployment system. Jed nodded slowly. Paz looked at her plate. Heike said, "The native mite system will be supplemented by the engineered cultures," Fen said. "I've reviewed the native biology. The mites are interesting, but insufficiently robust for the timeline we're working with." There was a silence. "The timeline," Heike said. 18 months to initial soil stabilization. Another silence, longer this time. "The timeline," Heike said again, in a slightly different tone, "is not 18 months. With the engineered system? Is not 18 months with any system," Heike said. "The thermal gradient alone, I've accounted for the gradient. With the correction factor?" Fen looked at her. "I'll review the 2189 paper on the transit," he said. He gathered his notes and thanked us for our time and left the table. We watched him go. I finished my second bread roll. "Well," said Jed after a moment. "Nobody added anything to that." The countermeasure. We stayed at the table for another 2 hours after Fen left. This is where I should clarify something for the record. We did not set out to humiliate Alistair Fen. We were not interested in humiliation. We were interested in a fragile alien ecosystem that had been developing in isolation for geological time, and that was, in our collective assessment, about to be seriously damaged by an engineered microbial system optimized for conditions that did not exist on the target world. The native mites were the key. They always had been. Fen had called them insufficiently robust, which suggested he had looked at their population density and drawn the wrong conclusion. Sparse populations in a low organic environment aren't weak. They're waiting. The biology was there. The network was there. The relationship between the mites and the deep root systems was there. Intact and patient and ready. It needed a catalyst. It needed a catalyst that would also, as a secondary function, prevent Fenn's engineered system from taking hold before the native biology could establish dominance. Paz drew a diagram on a napkin, the mite network as she understood it from the survey data. Nodes, not a web, each population cluster isolated by the low organic gaps between them. Heike looked at it and picked up a pen and drew lines between the nodes. The fireplug root system, she said. It's already the connective tissue, the mites use it. You're not working around the gaps, you're working through something that already crosses them. Paz looked at the diagram for a moment. Then she took the pen back and drew the catalyst entering at the root surface rather than the soil column. That was the correction to the correction. It mattered. I described the hog deployment model I'd been developing. The idea that you didn't need to seed the whole surface if you could seed the mites directly, and the mites would carry the strain into every corner of the network themselves. Faster than any aerial dispersal, more thorough, already calibrated to the local biology because it was the local biology. Jed listened to all of it and then said, "We need something the mites will carry." We talked until the common area staff started giving us looks. By the time we went to bed, we had the outline of a microbial strain, native in origin, based on the mite gut chemistry from the survey data we'd been given, self-limiting so it wouldn't outrun the ecosystem it was protecting and dominant enough in the target soil environment to occupy every niche Fenn's engineered system would need to establish itself. It would also, as an emergent property of its metabolic process, produce a compound that caused significant gastrointestinal distress in humans not acclimated to the local soil microbiome. This last effect was not central to the ecological model. We did not consider it disqualifying. The transit. We had 6 weeks on the transport to Big Blue Miner. The microbial strain took 3 weeks to develop and test on the soil samples we'd brought. Paz ran the cultures. Heike monitored the atmospheric interactions. I handled the integration with the mite biology, which was the part that mattered most. If the strain didn't carry right, the whole thing collapsed. It carried beautifully. Jed wrote most of the paper during the last 2 weeks of transit. The rest of us contributed sections in our areas. It was not a long paper, 12 pages, tight methodology, clear results, conservative conclusions. The kind of paper that the journals we were targeting would review quickly because it didn't ask for anything it couldn't prove. We submitted it with 3 days left in the transit. We did not tell Fenn. Fenn, for his part, spent the transit preparing his deployment protocol. He was thorough, he was organized. He had clearly reviewed the Brandt-Schiller correction factor because he stopped mentioning the 18-month timeline. He did not consult any of us, which was his right and also his mistake, and we did not offer. About 2 weeks in, I was running inventory on the mite collection gear in the equipment bay when Fenn came in. He stood in the doorway for a moment, then he came in and looked at what I was doing. "The mite collection apparatus," he said. "Yes." He was quiet. "The survey data shows a population density of roughly 4 individuals per square meter in the target zone," he said. "I assessed that as insufficient for the ecological role you're proposing." "I know," I said. "I've been looking at it again. The distribution isn't random, it's networked. The density figure I was working from describes nodes, not the full network." "The actual coverage is closer to continuous," I said. "Yes." He nodded. "The R. Okafor paper," he said. "The methodology section addresses this." I waited. "I read the abstract," he said. I looked up at that. He was looking at the collection gear. "The methodology section addresses it," I said. "Yes." He thanked me for my time and left. At dinner that night, he asked about the transit schedule and whether there'd been any update on the cargo delay from Waypoint Bravo-7. We told him what we knew. The conversation moved on. The conversations were fine. The planet. We deployed the native strain 2 days before landing, carried in atmospheric suspension ahead of the main transport. On the 3rd morning of surface surveys, I was running a mite density check on the east slope when Paz came up beside me and crouched down to look at what I was looking at. The mites were moving in column formation along the underside of a basalt shelf, not randomly, the way they moved in the survey data, but purposefully, the way a population moves when it has somewhere to go. They were carrying. You could see it under the loop, small dark loads, the new microbial cultures. being walked into the deep rock seams where Fenn's system would need to establish, and where, as of that morning, there was no longer any available chemistry for it. "Column formation," Paz said. "Since yesterday," I said. She stood up and looked out at the surface for a moment. "That's it then," she said. It was. Fenn's team had set up the engineered system deployment on the North Flat the day before. We could see the dispersal equipment from where we were standing. A row of atmospheric injectors, well placed, properly calibrated, exactly what you'd use if you were working a sterile world with no existing biology. Over the next 2 days, we watched the readings. Fenn's engineered cultures found no available niches. Not because the mites had fought them off, that's not how these things work, but because the mites had already been everywhere the engineered system needed to be. The native biology hadn't resisted. It had simply arrived first and done what healthy ecosystems do with foreign elements. Absorbed the question before anyone had finished asking it. The native system stabilized over the following weeks exactly as our paper had predicted, which was satisfying in the specific way that correct predictions are satisfying. Not triumphant, just right. Fenn became ill on the 3rd day of surface surveys, severely ill. The gastrointestinal situation was significant enough that he filed a medical report, which is in the official record somewhere if anyone wants to look for it. He attributed it to the transit food, which was also adequate but in a different way than the station food had been adequate. He continued working. I'll give him that. He was thorough, and he was committed, and even while quite unwell, he documented the surface conditions carefully and completely. The data he collected during that period is actually useful. We cited some of it later. After 2 weeks, he drafted a paper claiming the ecological stabilization as a result of his methodology. The paper. He submitted it to the Journal of Applied Planetary Ecology. The journal sent him a response in 11 days, which is fast. Journals move fast when they have already accepted a paper on the same topic. The response noted that the ecological dynamics of the target world had been documented in a recently accepted paper, submitted 6 weeks prior, currently in final review, and that the methodology described in that paper differed significantly from the approach described in his submission. They attached a copy for his reference. He read it on a Tuesday morning. I know this because I was eating breakfast when he came into the common area, holding his tablet with the expression of a man who has just understood something he would have preferred not to understand. He stood there for a moment. He looked at the table. Jed was eating eggs. Paz was reviewing sample data. Heike was drinking her own coffee, which she had somehow resupplied from somewhere, a mystery that none of us ever solved. I was eating breakfast. Fenn looked at the byline on the paper. Barnes, J.T. Vasquez Reyes, M. Brandt, H. Okafor, D.R. et al. He put the tablet down on the table. He sat down. He was quiet for a long time. "The mites," he said finally. "The mites," Jed agreed. Fenn looked out the viewport at the dusty red surface of Big Blue Minor, where the native ecosystem was quietly going about the business of becoming something. "The native system was always going to work," he said. "Yes," said Paz. "You knew before we left." "We had a strong hypothesis," she said. "The paper confirms it." Another silence. "The gastrointestinal situation," Fenn said. I looked at my breakfast. "Emergent property of the microbial metabolism," I said. "Documented in Section 4. He nodded slowly. He picked up his tablet. He looked at the paper for another moment. Then he put it down and asked if anyone wanted more coffee. Heike said no without looking up. The rest of us said yes. Final note. Alistair Fenn went back to Ganymede after the mission. He published 3 more papers in the following years, 2 of which cited our Big Blue Minor work in the methodology sections. Good papers, careful work. The kind of papers a man writes when he has learned something he didn't expect to learn and decided to use it rather than ignore it. We never discussed the dinner table briefing again. Not with him, and not really among ourselves. There wasn't much to say. The work had gone well. The planet was doing what planets do when you pay attention to what they already know. That's the whole story, except for one thing. The night after Fenn read the paper, I was doing a late equipment check on the East Ridge when Jed came out to help, which he does sometimes when he can't sleep and there's work available. We did the check without talking much, which is how Jed and I usually work. On the way back in, we stopped for a minute and looked at Big Blue hanging in the dark above us. "He wasn't wrong about everything," Jed said. "No," I said. "The professor just got there late." I had no argument with that. End of recorded testimony. Witness requested that the final paragraph be struck from the official record on the grounds that it was too neat. Request considered. Denied. The coffee was noted for the record at witness's insistence.
Vicious Planets is a science fiction podcast about hostile worlds, bad systems, cosmic mistakes, and ordinary people caught in forces too large to fight. These aren't stories about heroes. They're stories about people who do the work anyway. This episode is a work of fiction. Any resemblance to real planets, real livestock, or real procurement officers who approve something they did not fully read is entirely coincidental. Nothing here constitutes legal, medical, agricultural, or veterinary advice. Do not attempt to terraform a world based on this transmission, and do not throw hogs at a problem without first consulting somebody who is not the contractor. The Interstellar Agricultural Oversight Board has reviewed these statements and asked that they be restated in standard terms. The contractor declined. He is also keeping the hat. File all forms in triplicate. Always know where your oxygen tank is at.
Okay, hear me out, Mr. Producer. 5 seasons, 11 episodes, and a movie.
Laboratory lab coat said the atmosphere was dead. They ran a million schemers, but we brought a plow instead. We dumped the microbes in the sill, poured coffee in the clay, and prayed those little mites would find a way. Clones got too expensive, so they threw us at the dirt. We brought mites, roots, and coffee, and made that dead world work. They had models, we had weather, they had charts, we had the ground. When the planet started breathing, we were too tired to write it down. Yeah, we made it work.